Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning to all students of 3 Amethyst. Okay, while we are waiting for your friend to come in, so we make a revision about what we have learned yesterday by doing several questions regarding question in the formative practice 4.2. Okay, before we proceed to 4.3. Okay, can you see my sharing presentation?
Yes.
Okay. Okay, so based on what we have discussed yesterday, okay, about 4.2, about the reactivity series of metals. So we have concluded that the reactivity series of metal, okay, will comprise of this one, starting from potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, hydrogen, iron, tin, okay, tin, lead, copper, mercury, silver, and gold. So this is the name of metal that is that are included into the reactivity series of metal, and their symbol is given here. So even though you are not required to remember all these things about the symbol, but hopefully better for you to try to memorize symbol, what it represents, the metal itself. For example, we can see from here tin. So the symbol is SN. So SN exactly stand for what? So stand for stannum. Iron. The symbol is Fe. So as Fe itself is derived from ferrum. Ferrum. Same with this one, mercury. So the symbol, chemical symbol is Hg. Gold is Au, aurium, and so on. So I want you to remember the sequence, the correct sequence of this reactivity series of metals. So this reactivity series of metals is based on the reactivity. So reactivity, the vigorous, vigor of this metal when react with oxygen gas. So based on the reaction towards oxygen gas, so they have different reactivity, and the most reactive metal is at the upper position. So the upper position here, potassium, is the most reactive metals. And then when going down this series, the reactivity decreases. Or based on this textbook, when going up from the bottom position, the lower position here from gold, until when going up to the top position, so the reactivity of metal towards oxygen increases. Yeah. So now we try to look back into the question in the textbook. Yeah. So question number 1, I have explained to you just now what is reactivity series of metals. Yeah. So you must know that reactivity series of metal is a sequence of reactivity of that metal towards oxygen. And inside the reactivity series of metals, there are two non-metals that also reactive toward oxygen. That is carbon and hydrogen. Yeah? Carbon and hydrogen also included into this reactivity series of metal, even though they are non-metal, because they also have a reaction towards oxygen. Yeah, the same as the characteristic by the metal itself. Yeah. Okay, question number 2. Yeah, question number 2. Okay, figure 1 shows the reaction between metal X and oxygen in the air. Yeah, so the figure 1, okay, now produce flame here. There is a bright flame, yeah, produce here. The reaction between metal X and oxygen in the air. Yeah. Okay, so the question here is, A, is the metal X reactive toward oxygen? Explain your answer. Yeah. So, okay, as we have learned before, yeah, if the reaction occur, means that, okay, if the reaction occur between metal and oxygen, okay, so based on this one, okay, sorry, so this one metal X, so metal X, if we look back at the reaction, based on the experiment that we have discussed yesterday, the reaction is between, okay, I don't want you to confuse. Yeah. For example, carbon, yeah, what we have discussed yesterday, carbon and metal oxide. Yeah. Okay. And then the reactivity series of metal is based on the metal react with oxygen. So the vigorous of reaction, the comparison of vigorosity of reaction between metal and oxygen is compared. So when any metal react with oxygen with a bright flame compared to the metal that react with oxygen with very low flame, so we can consider that metal that is react with bright flame is more vigorous or more reactive compared to the metal that is react with a low flame. So based on the vigorosity of the flame or the reaction, so we arrange the reactivity of metals. So this one, when metal react with oxygen, so we will base on the observation that we made. Okay, so if we observe from this experiment, so we can see that it produce flame, brightly flame, or very brightly flame. So it will produce like this. So what we can say that is the metal X reactive toward oxygen? So we can say yes. Yeah. Okay, explain your answer. Okay, so the explanation is this one. Yeah, because when metal X react with oxygen, it produce very bright flame. Yeah, so the production of flame like this one shows that the reaction is very reactive. Yeah. Okay, so that is the explanation for this question. Yeah. B. Yeah. Metal Y glows brightly, glows berbara when it reacts with oxygen. Is metal Y more or less reactive than metal X? Yeah. So if we compare the vigorosity or the reactive of this reaction, based on the observation given, so we can say that metal X, okay, produce flame that is very bright, yeah, while metal Y, yeah, the bright produce is just a glowing, just a glow brightly when react with oxygen. So based on this observation, so we can know that metal X is more reactive than metal Y when react with oxygen. So we just based on the observation produced by the reaction. So question B, the answer is based on the reaction produced. So we can say that metal is metal Y. Okay, metal Y is more reactive. So that is the way on how to answer this one. How to compare the reactivity of metals. Metal Y is more reactive than metal X.
Cikgu, bukan metal white is less reactive ke?
Sorry. Okay, sorry. Metal X. Based on this one, okay, metal X is more reactive than metal Y. Okay, thank you very much. Okay, so metal X very bright, and then metal Y just glow. So based on this one, metal X, this metal Y glow. Okay, so metal X is more reactive than metal Y. Okay, okay. Next, question C. Okay, if metal Z does not react with oxygen, so arrange X, Y, and Z in the reactivity series of metal based on their reaction. So now metal Z, no reaction. No reaction. So based on this one, so we can arrange the reactivity series of this metal based on their reaction. So we can say that, okay, the upper position is more reactive. So we can arrange X, Y, and Z. So we can see that like this. Reactivity decreases. Okay. Reactivity of metals decreases when going down the series. Yeah? So reactivity series decreases, reactivity of metals decreases, yeah, when going down the series. Yeah, so this is how to write the answer, yeah, and how to explain, yeah, regarding this question. Yeah. Okay, question C. Okay, yeah. Question C. Okay, so this one, you have to fill in this one, C. So X, Y, Z, X, Y, Z. Okay, question number 3. Underline the correct answer. Twenty 22. Amira, Dia, Fatin, Ahmad, Matis, Muhammad, Muhammad Listari, Muhammad Zarfan, Nur Aisyah, Putri, Anisha, Kanak. Okay, question number 3. Okay, underline the correct answer. Metals are arranged in the reactivity series of metal based on the reaction of the metal towards. Okay, metal are arranged in the reactivity series of metals based on the reaction of the metal towards oxygen. Yeah, okay, so that is
Oxygen.
the concept that is being used in constructing the reactivity series of metal. B, the most reactive metal in the reactivity series of metal is calcium or potassium?
Potassium.
Potassium. Okay, very good. C, the reactivity. Okay, potassium, the symbol is K. Yeah. Better for you to try to remember lah. Calcium is Ca. Okay, Okay, C. Yeah. The reactivity series of metal is applied in the
Extraction.
of metal
Extraction.
from their ore. Extraction. Okay. Yeah. 4. State the most 4A. State the most reactive metal in the reactivity series of metal.
Potassium.
Potassium. So this one all is the basic question. State the least. State the least reactive metal. Okay, the least means that. Okay, the least.
Gold.
Gold. Yeah. Aurium or gold. G-O-L-D. Okay. Number 5, state two non-metals element that are included in the reactivity series of metal, carbon, and
Hydrogen.
hydrogen. Okay, please remember. B, why are these two non-metals element included in the reactivity series of metal?
They
Why?
can react with
Because they
oxygen.
react
Because they can react.
With oxygen.
They can react. Let's see, with oxygen. Oxygen gas. Okay, so that's why we have to compare their reaction with other metal reaction. Okay, so now we proceed to the 4.3, extraction of metals from their ores. Okay, so the metal that we found mostly in the lab exactly is not in that natural way. Exactly the metals in the natural that we get is exactly in the form of ore. Or in BM we say it as a BG. Okay. So we have except silver and gold. Okay, silver and gold exactly can be found naturally on their own types of metals. So they are in individuals type of metals. So they are not combined with other elements to form ore. So that's why gold and silver itself, gold and silver become most popular metals and very high precious metal, high demand because they exist naturally in their own form, as a gold and as a silver. But for other metals, we have they exist naturally in a compound form. So in the compound form, so they will exist, they will combine with other elements. So what we have to do, we have to extract this metal from their compound or from their ore itself. Okay, so based on this one, based on their reactivity series of metals, so we are using different types of methods to extract the metal from their ores. So we have to use method to extract metals from their ore. So based on the reactivity series, so we can do like this. Based on your textbook, for the metals of the upper position, potassium, sodium, calcium, magnesium, aluminium, okay, until aluminium. So the methods of extraction, the method of extraction that being used is through the process of what we call as a electrolysis. Electrolysis. Okay, this electrolysis, electrolysis. We are using electric and the electric circuit, and then we put into the melt of this ore, and then what will happen is based on the electric current that is produced, so we can separate the component that made up the compound itself. So by using electric, we can separate and we can extract the metal from their compound. So you have to remember, in order for us to extract this upper position metal, so we have to use the methods of electrolysis. Electrolysis. For metal from zinc, iron, tin, okay, and lead. So we have 4 metal here, zinc, iron, tin, and lead. Okay, the method that we are using is by react the metal oxide, the natural compound. Yeah? This is the natural compound in the ore. Okay, so this metal oxides, we will react with carbon. Yeah. So when react with carbon, as we know that carbon is more reactive than zinc, iron, tin, and lead. So carbon can separate the metal below carbon from their oxide. Yeah. So this is the way on how we can separate metal from their natural compound, by the process of heating metal oxide and carbon. Yeah. Okay, same as the experiment that we have discussed previously. Okay, next, for copper and mercury, yeah. So the extraction of this metal is based on the direct heating of the metallic compound. Yeah. Okay, so direct heating of the metallic compound. So we take the natural compound or the ore, and then we just heat direct into this natural compound, so we can separate the copper and mercury. That is the method. And for silver and gold, so these two types of metal exist in the form of elements in earth crust. Okay, so there are four methods. Electrolysis, okay, reduction process with carbon, direct heating, and this one, silver and gold, no method. So exactly no method for this one. So we have three methods for different metals to extract the metal from their ore. So I hope that you can remember the methods given here based on the different metals. Okay, so in your syllabus, we are discussing about how to extract, how to extract this one, iron. Process of iron extraction. Okay, so in industry, the extraction of iron from its ore is carried out in a blast furnace as shown in the figure. Okay, this is in the industry, in the factory. When we got the iron ore, so this iron ore will put into this blast furnace. So this blast furnace exactly is a very, very high temperature and pressure. So the exactly very complicated, but the diagram shows as simple as this one. Just to show you about the simple explanation about how iron is extracted from their ore. Okay, so now we have ore like this. Okay, and then a very hot air is pumped into the furnace through the bottom. So from here, a very hot air is put in, and then it will make the ore become hot. So from this one, when the ore, it will become melt. Yeah. So what will happen is, what will happen is, it will produce the molten metal at the bottom. Yeah. So the iron will be deposited at the bottom of the blast furnace, and then will be collected from this blast furnace. This diagram. This is a simple diagram. Exactly the real one is very complicated. Okay.
Teacher,
So from this reaction, so we can get all this molten metal. Okay, what is exactly happen inside the blast furnace is like this. So
Teacher, ada
yes,
orang panggil tadi teacher.
hello,
hello teacher.
yes.
What is slag?
Okay, slag. Okay, this one, slag is exactly the, we can say this is the impurities. Yeah. So inside the iron ore, for example, so we can extract iron, and then beside iron, exactly inside the iron ore consists of a lot of other elements and other impurities. Impurities mean other than iron lah. Yeah. So all this one will be accumulated, and then when they melt, so they will be collected at the different part. So slag is exactly in BM slag impurities. Impurities lah, maksudnya bahan selain daripada iron. Yang kita tak perlukan. We exactly no need this element, no need of these impurities. Means that the natural or the mineral beside the iron, inside the iron ore. So we accumulate this, we call it as this one as a slag. Okay, so after we got this one, there is another or other process in which we can extract other element from this slag. Okay, we can consider this as impurities in the iron ore. Okay, next. Okay, this is exactly what happened inside the blast furnace. Okay, I want you to remember all this one if you can. If you can. Okay, production of iron. Okay, the first one is carbon will react with oxygen to form carbon dioxide. And then carbon dioxide will react with the rest of the carbon, okay, to form carbon monoxide. So we have two types, different carbon here. Carbon dioxide is gas, carbon monoxide is also gas, but there are different in the term of chemical characteristic. So carbon dioxide gas will be produced, and then this carbon dioxide gas will be further react with the rest of the carbon to form carbon monoxide, MONO. This one, mono diode. Okay, so carbon monoxide, the symbol is CO. Okay, from this carbon monoxide, so carbon monoxide and carbon will reduce iron oxide to form iron. So exactly, we are using carbon monoxide and carbon in order for us to extract iron from the iron oxide. So this is several equation represent the reaction. The first one, iron 3 oxide react with carbon, so it will form iron and carbon dioxide. Next, iron 3 oxide react with carbon monoxide, it will form iron and carbon dioxide. Iron 2 oxide with carbon will produce iron and carbon dioxide. And the last one, iron 2 oxide react with carbon monoxide, it will produce iron and carbon dioxide. Yeah. Okay, so this one exactly the slag. Okay, this one. Yeah, so I want you to remember this one exactly. The name, the chemical name is given here. Yeah. Okay, limestone or chemical name is calcium carbonate decomposes, terurai to form calcium oxide and carbon dioxide. Yeah. Okay, this is the equation. Calcium carbonate decomposes to form calcium oxide and carbon dioxide. Yeah. Okay, so what will happen is, okay, this one is a calcium, not iron, but in iron ore, so it will mix together with other elements. Yeah. So inside the any ore itself, there are lots of other elements and natural compounds. So they mix together. So the most important thing, how we want to extract the metal itself. So the other element, other natural form will be put aside, and there is a methods on how to extract that natural compound itself. So this one, when we have this one, calcium oxide will react with impurities, such as sand, silicon dioxide in iron ore to form this one, or calcium silicate. So the slag itself is a calcium silicate. What is a calcium silicate? It is consists of calcium, silicon, and oxygen. Sand is a silicon dioxide. Inside the sand is silicon and oxygen. So when calcium oxide react with silicon dioxide, so it will form calcium silicate. So this calcium silicate will form a slag. So I hope that you can remember all the reaction that occur in the furnace, from the production of iron and also the production of slag. So even though this is very complex exactly, but try to remember the name of this chemical compound used in the process. Okay, so this one, the conclusion of this extraction process. Iron that is produced will melt. Okay, this molten iron flows to the bottom part of the furnace. From time to time, the molten iron is tapped off and channeled into mold and allowed to cool and freeze. The molten iron that has solidified is known as cast iron. Okay, slag is produced with melt. This molten slag also flows to the bottom part of the furnace. So since molten slag is less than molten iron, the slag will float on top of the molten iron. From time to time, the molten slag is tapped off and used to make the base of building and roads. So that is the conclusion about the iron extraction. Okay, the last one, this one you can read on your own. Mining issues in Malaysia. So because the extraction process exactly very tough issues because will lead to the pollution itself. Yeah? So there is a mining issues in Malaysia, very dangerous one. Yeah? We cannot simply just extract the metal from their ore by doing something that we can by using all the method given, because in reality there is a problem. Yeah? So there is a rules and regulation that have to be faced by the industry in order for them to extract the metal from this ore. Okay, so we finish the chapter 4 point subtopic 4.3, and then so I hope that you can as usual write the notes for this subtopic 4.3, and then do the formative practice 4.3, and also in the um, science process book. Yeah. Okay. So okay, for this summative practice, okay, we have about 6 questions. Okay, 6 questions. Okay, I want you to try to answer this one. Question number 1, number 2, okay, number 3, okay, 4, 5, and 6. 6. Okay, until number 5 only, eh? Number 1 until number 5. Okay, so I want you to do this as this exercise in your book, in your book. Okay. So we finish chapter 4, and then the next chapter is this one, also chemistry, chapter 5, thermochemistry. The new syllabus in your form 3, exactly this one in the chemistry subject, but lowered down to your parts. Exactly, this is highest syllabus in form 4. Yeah. Okay, so any question from you regarding the chapter 4?
No, teacher.
No, teacher.
Okay, so that's all for today. So I hope that you can finish all the notes and the exercise given in the textbooks and also in your module science process book. So please write down your name in the WhatsApp group for your attendance. Okay, so
Teacher,
thank you very much. Yes,
yang summative practice tu kena hantar kat teacher ke lepas siap?
pardon?
After finish doing it, to have to take
Yes, yes,
photo and
yes,
send
yes.
to teacher.
You have to submit your what you have done in your exercise book to my Telegram, please, to my Telegram.
Latest,
Don't submit through WhatsApp because very large memory.
okay
To
teacher.
Telegram.
Last submit bila teacher?
Last submit.
Uh,
Last submit. I cannot give you any date. So as soon as possible lah.
oh okay teacher.
As soon as possible. Okay. So thank
Okay,
you very much
bye-bye.
for your attendance. Okay, you can leave the meeting right now. Thank you very much.
Okay,
Okay.
teacher. Bye.
Thank you teacher,
Bye.
Thank you,
bye-bye.
teacher.
Thank you, teacher. Bye-bye.
Bye.
Thank you, teacher.
Okay, thank you, teacher.
Okay.
Thank you, teacher.
You are welcome.